Here we have a LC circuit without a resistor. In such a case, we can apply the Karkov voltage loop law and get an equation for the Q. So let's see. First, the voltage drop across an inductor is L times di dt, and that's because inductors tries to counter any changes in the current. It tries to go against the changes in current. So that's the voltage drop. And in a capacitor, the amount of charge inside the capacitor is proportional to the voltage applied. So the voltage drop is proportional to Q, and that coefficient is called capacitance 1 over C. And since this is all the components inside one loop, they have to add to 0 because of the Karkov's loop law. Then you use the fact that the derivative of Q, the change of charge with respect to time, is the current, because current is the flow of charge, right? And therefore the derivative of I would be the second derivative of Q. And then finally you multiply by -1 to make this into positive, and that's the differential equation for the charge inside a LC circuit. All right, so for this one, let's try to solve it for L equals to 49. So 49 Q double prime plus C is 1, so it's 1 over 1. Q equals to 0, or this would simply be just 1. And therefore, to solve this, you would need to write down the characteristic equation, which is like 49R squared plus 1 equals to 0, which says R squared is equal to -1 over 49. And the square root of 1 over 49 is 1 over 7. Square root of -1 would be plus minus I. So you get the value of R equals to -1 over 7. I, actually plus or minus. And it's really like 0 plus minus 1 over 7i, because you can use the formula that the solution is e to the at times c1 cosine bt plus c2 sine bt, where A and B are the two values. The real part will be the A, and 1/7 will be the B. In our case, A is 0, so e to the 0th part is just 1, so you don't need this at all. And B would be equals to 1 over 7. And this one, 1 over 7. Okay, next, what you do is you take the initial condition. Well, we also need I of 0 equals to 4 means Q prime of 0 is 4, so we need the derivative. So let's try to find the derivative. Q prime of t would be just a simple application of the chain rule. Cosine differentiates to negative sign, and this 1/7 comes in front, so you have -1/7 times C1 sine 1/7 t plus 1/7 C2 times cosine 1/7 t. Okay, and now we apply the initial conditions. So first of all, Q of 0 is equal to 0, but according to this formula here, if you plug in 0, cosine 0 is 1, whereas sine of 0 is 0, so you just get C1. And therefore C1 has to be 0. Okay? And then secondly, if you plug in Q prime of 0, then sine of 0 is 0, so there's no C1, but you just get 1 over 7 C2. Cosine 0 is 1, so you just get this, and that has to equal to 4. And therefore, if you solve for C2, you see that C2 must be 28 by multiplying by 7 both sides. And then finally, you plug in these values back into Q, and therefore the final answer for Q would be Q of t equals to 28 sine 1/7 t. So that's the answer. Now, in some cases, they ask you to write the solution into cosine, and this is a rare case where you can't use the formula tangent inverse b over a because you have this c1 is 0, so 20 over 0 would be not defined. So here you have to use some identity that says, when you have the graph of, if you have the graph of sine, and then if you compare that with the graph of the cosine, that goes like that, right? If you take the sine and shift it left by 90 degrees, you get the cosine graph. And the way you can shift it is by adding 90 degrees. So this one really says that there's this identity that you should know, which is that if you take sine function and you do x plus pi over 2, you get cosine of x, and also vice versa. You could take the cosine function and shift it 9 degrees to the right, which means x minus pi over 2, and that's going to give you sine of x. Actually, this is what we should use. So if we use this second identity, not this one, then you can furthermore rewrite this one as 28 cosine 1/7 t minus pi over 2. Okay, and this way you see that the phase angle is pi over 2, amplitude is 28, and angular frequency is 1/7, and all that. Okay, so usually this would be enough to as an answer, but sometimes the question might say express the answer in terms of cosine. For this special case, you may have to use this.